Name of the subject, internal combustion engines. Name of chapter, introduction. Name of topic, working of 4-stroke engine. Contents, working of 4-stroke SI and CI engines. Dear friends, today we are going to discuss on very important point in the IC engine, that is the working principle of 4-stroke SI engine and 4-stroke CI engine. So in the last few lectures we already discussed about the definition of engine, engine classification, its nomenclature, then Otto cycle, diesel cycle, and the deviation between the Otto cycle's actual engine and the ideal cycle. Okay, with the help of the different reasons. So today we are going to discuss on very important point, that is the working of 4-stroke SI and CI engine. So with the help of this 4 diagram, we are going to discuss about the working of 4-stroke engine. So always remember, in the case of 4-stroke engine, there are 2 revolutions of the crankshaft. So what do you mean by the 2 revolutions of the crankshaft? So always crankshaft rotate in a clockwise direction in 360-degree rotation. Okay. One 360-degree rotation completes 1 revolution of the crankshaft. Another 360-degree rotates, that is second revolution of the crankshaft. So for completion of the process, in the case of 4-stroke engine, the crankshaft will rotate in 2 revolutions, or we can say in 720-degree, that is 360 plus 360, that is 720-degree revolution or rotation of the crankshaft. So let us consider again, here we have a cut section model of engine, a single cylinder engine. Suppose there is one 2-wheeler and we have a 2-wheeler engine with us, and we have cutted it down from the middle of it, and this is the cut section of it. Again, the 2 walls, this is the inlet wall, this is the exhaust wall, and this is the inlet section. Here is the spark plug. This is the cylinder, and this is the piston along with the connecting rod which connect to the crankshaft. And this is the crankcase, or we can say this is the complete engine assembly. Okay, so initially what happens, suppose when you are going to apply some foot pressure on the kick of the vehicle, that time what happens, this crankshaft will start to rotate in clockwise direction, and at the same time, because of the connecting rod, piston will start to reciprocate initially from TDC to BDC. Okay, so let us consider one more device which is connected to the engine inlet, and that device is nothing but called as a carburetor. Later on we have to discuss on the carburetor also, but right now you just remember, it is a device which is used to supply the required amount of air and fuel mixture inside the engine cylinder. Dear friends, always remember, for burning of any kind of a fuel, there is a requirement of oxygen. So the oxygen is present in the atmosphere in the form of air. So carburetor is a device which is used to supply the required amount of the fuel and oxygen in the form of air to the engine cylinder, and that device which is attached to the inlet section of the engine. So initially what happened, when the piston is moving from TDC to BDC, that time some amount of vacuum will create inside the engine cylinder, and at the same time the camshaft, because of the camshaft operation, this particular inlet wall should open, and at the same time the exhaust wall remain closed, and through this particular inlet wall, the amount of air and fuel mixture through the carburetor will come inside the engine cylinder, and this is called a chamber of the cylinder. Okay, so this process is called the suction process or intake process. During suction or intake process, what happens, the piston will move from initially TDC to BDC, and through the inlet wall, the amount of air and fuel mixture will come inside the engine cylinder. This is called process of suction or intake process. Okay, suction means what? I think if you can take the example of the process of suction, whenever the piston will move from the top portion to bottom portion, some amount of a kind of vacuum may create inside this chamber, and because of the creation of vacuum, the amount of air fuel mixture will get sucked inside the engine cylinder. Okay, such kind of a process is called as the suction or intake process. Now similarly, the second process is called as the compression process. So during this suction process, the revolution of the crankshaft is half revolution, or we can say it will rotate in 180-degree rotation of the crankshaft. So this stroke will happen within half revolution or 180-degree rotation of the crankshaft itself. So similarly, the next stroke or next process in the 4-stroke engine is a compression process. So we are talking about SI engine first. So here fuel is a petrol. Let us consider. So during compression process, now because of the self inertia, the piston will move from bottom dead center to top dead center, and whatever amount of air and fuel mixture is present inside this particular cylinder, it will get compressed. See the direction of motion of the piston, BDC to TDC. Because of this process of compressing the air fuel mixture, this is called the compression stroke. I think you understand the inlet or intake or suction process as well as the compression process. And during compression process, again this particular crankshaft will move next 180-degree, that is next half revolution. Means suction and compression will happen within one revolution of the crankshaft, that is 360-degree rotation of the crankshaft. During suction, piston will move from TDC to BDC. During compression, piston will move from BDC to TDC. Okay, this again up to this suction and compression, there is no any kind of burning will start to take place. Only piston is moving from TDC to BDC and BDC to TDC because of the self inertia. I think all of you are knowing about the example of self inertia. If you can take the example of your bicycle, whenever you are going to apply some pedal pressure force on the pedal of the bicycle, and when you leave some pressure or effort from that particular pedal, even that will rotate for some duration. That is the example of that particular self inertia. So such kind of a self inertia will also present inside this particular engine cylinder, and because of the self inertia, piston will always moving from BDC to TDC during the compression process, and whatever amount of air fuel mixture is present, it will get compressed. So this is called the process of compression, and during this process both the valve will remain closed. So for working and closing of the valves, this particular valve mechanisms will be present over there. Later on we will talk about this also. So the next process is a power or expansion stroke. So what will happen during this process? This is again very interesting and important one. So here is the spark plug. So what happened, dear friends, in this case, at the end of the compression stroke, when the piston is reaches to top dead center, at the same time spark plug provides the spark inside the engine cylinder. Okay, so because of compression process, water amount of air and fuel mixture which coming inside the engine cylinder during suction process, that will get compression, and its temperature and pressure will going to increase tremendously, and inside that high temperature and pressurized that particular air fuel mixture, inside that once the spark plug provides some amount of ignition, and that air fuel mixture will start to burn. The burning will start to take place, and again because of the burning, that air fuel mixture will get converted into gaseous form, and the gaseous pressure will apply on the piston surface. Again it creates some amount of pressure force on the piston surface, piston top surface, and it pushes down piston again from TDC to BDC. So gases will start to expand inside the engine cylinder. So this process is called as the power stroke or the expansion stroke. Okay, this chamber is called as the combustion chamber, where these all things are happening. So during the process of power or expansion, piston will move from TDC to BDC. Look at the direction of motion of the piston, and finally again piston will move from bottom to top dead center. Whatever exhaust gases are present inside the engine cylinder, that should be leave to the atmosphere, so that the exhaust valve will remain open, and because of this opening of exhaust valve, whatever gases are present inside the engine cylinder, that will send to the atmosphere. That is nothing but the exhaust gases will come out from the silencer. Okay, so during this process the inlet valve remain closed, only exhaust valve remain open. During the process of expansion or power, both the valves are remain closed. So again these two processes will happen within next 180-degree revolution of the crankshaft, or half revolution, 180-degree rotation of the crankshaft and half revolution of the crankshaft, and similarly exhaust will happen in the next 180-degree rotation of the crankshaft. So this suction and compression will happen in one revolution of the crankshaft, and expansion and exhaust will happen in next one revolution of the camshaft. That is nothing but called as in the case of 4-stroke SI engine working, there will be always 4-stroke of the piston, that is intake or suction, compression, power or expansion, exhaust, and there will be a 2 revolution of the crankshaft, that is total 720-degree rotation of the crankshaft. Okay, so I hope you understood with the help of this particular theoretical diagram the working principle of 4-stroke engine. So as we just discussed the working of 4-stroke SI engine, that is about the petrol engine. Now dear friends, when we are going to discuss about the diesel engine, that is nothing but called as the working of 4-stroke compression ignition engine, that is CI engine. Diesel engine is always called as a compression ignition engine. Okay, so again all the things are very much same. Let us assume again the inlet valve, exhaust valve, piston, cylinder, crankshaft, connecting rod, everything is same. Only just consider this spark plug is replaced by the injector in the case of 4-stroke CI engine or diesel engine. Okay, the conventional type of 4-stroke CI engine and diesel engine, there is no need of spark plug. Instead of spark plug, let us assume here is a injector. What is the role of injector? Later on we have to discuss, we have to talk on the injector also. You just remember, injector is a device which is generally used to supply or inject the amount of diesel in the form of a spray inside the engine cylinder. Okay, so with this consideration we are going to again understand the working of 4-stroke CI engine. Again everything is same, there will be a 2 revolution of the crankshaft, that is 720-degree. Then again there will be a 4-stroke suction, compression, expansion and exhaust. This is same. So during suction in the case of CI engine, what happen? Instead of air and fuel mixture, only air will get come inside the engine cylinder. Okay, please concentrate the difference. Please understand the difference between SI and CI engine. In the case of SI engine, through the carburetor, there will be always the amount of air and fuel. Both will come inside the engine cylinder. But in the case of CI engine or diesel engine, only atmospheric air will come inside the engine cylinder. And this is called the suction process. And similarly, during compression process, only that atmospheric air will get compresses. Still there is no any kind of a fuel coming inside the engine cylinder or come inside the engine cylinder. Okay, so at the end of compression stroke, so during suction only air will get come inside the engine cylinder. During compression only air will get compresses. So because of compression process, that air should compress within the very low volume or within this particular space itself. That's why its temperature will going to increases. Now at the end of compression stroke, again let us consider, suppose this is the injector. This injector injects the diesel spray inside the hot air, and ultimately because of the diesel spray come inside the engine cylinder, again burning will start to take place and expansion process will start. Again piston move from this TDC to BDC. The power is produced inside the engine cylinder. This is the third process, and finally again piston will move from BDC to TDC and exhaust gases will move out to the atmosphere through this particular exhaust valve. So this is the working of 4-stroke CI engine. So the basic difference between the 4-stroke SI and CI engine is what? In the case of 4-stroke SI engine, we are sending amount of air and fuel mixture inside the engine cylinder during suction process, and that will get compresses and the further processes will happen. But in the case of CI engine, only air will get come inside the engine cylinder during suction, and that air only get compressor during compression, and at the end of compression stroke, the injector inject the diesel in the hot air. Because of this compression process, the temperature of air will get increases. So inside that hot air, the injector inject the amount of diesel. It will spread the amount of diesel inside the engine cylinder, and burning will start to take place, and the further processes will happen. Okay, other things are very much same as compared with the 4-stroke SI engine. Hope you understand the working of 4-stroke SI and 4-stroke CI engine. So now to understand this working, whatever things we discussed theoretically, now with the help of few animations video, we are going to understand thoroughly the working principles. Okay, so we directed to see the different videos of it, so it will be better to understand. We start with the 4-stroke engine working. Please concentrate on the video. It is self-explanatory, and these videos are very beneficial to you to understand the working principle. Whatever things we learn theoretically, now with the help of this it will get clear. Please concentrate on the video.
A basic lesson in the fundamentals of a 4-stroke EFI gas engine may be helpful to your understanding of Mercury products. Here are the basic components of every 4-stroke gas engine: a piston, a connecting rod, a crankshaft. As the piston travels up and down in the cylinder, this lateral motion is turned into a rotating motion at the crankshaft. The longer the stroke of the piston, the larger the displacement of gas and air occurs in the cylinder. To propel that piston, we need to ignite a tiny bit of gas and a whole lot of air. This creates expansion inside the cylinder. The fuel delivery system consists of an air intake manifold, valves, intake and exhaust, a fuel injector, and a spark plug. A 4-stroke engine is called a 4-stroke because 4 up and down motions are needed to complete the cycle. In the first stroke, the piston travels downward as the intake valve opens and a mixture of air from the atmosphere and a metered amount of gas from the electronic fuel injector enter the cylinder. This is called the intake stroke. On the second stroke, the piston travels upward, compressing the air and fuel to make a highly combustible mixture. This is called the compression stroke. At this point, the spark plug fires, sending the piston downward from the expansion of the air and gas mixture. This is the combustion stroke. The fourth stroke is the exhaust stroke. As the piston travels upward, the exhaust valve opens to release the burned air-fuel mixture. When the piston reaches the top of this stroke, the intake valve opens and the cycle begins all over again. It takes one up and down motion or 2 strokes of the piston to create 1 revolution of the crankshaft. RPMs, or revolutions per minute, is how many times the crankshaft rotates within that minute. At wide open throttle, the crankshaft may turn at 5,000 RPMs, or a dizzyingly 83 times per second. Meanwhile, the piston traveled up and down 166 times in that same second. Want to see how fast that is? Now, that's fast. Let's see it again. Amazingly, the 4-stroke EFI engine does this smoothly, quietly, and reliably for years and years of operation.
Yes, I think this video is very much helpful to you to understand the working principle of the 4-stroke engine. So in this video, if you observe the spark plug along with the injector, this is a modern kind of engine, but you just consider right now this is a SI engine as well as the CI engine. The suction, compression, expansion and exhaust. The four processes are involved, and how the piston will reciprocate from TDC to BDC and BDC to TDC, as everything we learn with the help of this particular video. So this is again helpful video. So another video we have, with the help of this video the more clear idea you will get about the working. Please see.
This section looks at major components of the 4-stroke and 2-stroke petrol engine. Because they operate on similar principles, many of their components are similar too. For example, their engine blocks both operate under working conditions of very high pressures and temperatures. And new designs and materials to make them work more efficiently are always being tested. Many vehicles still use cast iron, but some have aluminium alloy blocks. The main gain is a saving in weight. Aluminium alloys can be made as strong as cast iron, but they're lighter. This is also true for cylinder heads. Combustion chambers in the cylinder head come in many different designs. To help hold in the extreme heat and pressure of combustion, a seal is made between the block and cylinder head by a head gasket. The 4-stroke petrol engine has other passages cast into the head to carry oil for lubrication and coolant for cooling. What is a stroke? It's the movement of the piston from top dead center to bottom dead center. Calling an engine 4-stroke means its engine cycle has 4 strokes. A 4-stroke petrol engine uses internal combustion, so those 4 strokes must include the 5 key events common to all internal combustion engines: intake, compression, ignition, power and exhaust. Let's look at a simplified model. The intake stroke starts with the exhaust valve closed, the inlet valve opening, and the piston at its highest point, top dead center. It starts to move down, increasing the volume above the top of the piston. This makes pressure inside the cylinder lower than pressure outside. This higher outside air pressure forces air-fuel mixture into the cylinder. The piston reaches bottom dead center, the inlet valve closes, and the intake stroke ends. Both valves stay closed as the piston leaves bottom dead center. The piston moves up, squeezing the air-fuel mixture into a smaller and smaller volume, which compresses it. That makes its temperature rise, and that makes combustion easier. Just before the piston reaches top dead center, the next key event occurs: ignition. Burning, expanding gas generates the force to push down the piston. This is the power stroke that drives the engine. The piston now moves from bottom dead center to top dead center. The exhaust valve opens and the piston pushes out the leftover gases. Let's look at the cycle operating. Intake takes in air-fuel mixture. Compression squeezes the air-fuel mixture into a smaller and smaller volume. Ignition, the mixture under pressure is burned. Power, burning expanding gases push the piston down, creating a power stroke that turns the crankshaft. Exhaust, the piston moves upward, forcing burned gases from the chamber. All 5 events occur in this order in each of the engine cylinders.
Yes, hope you understood in well manner everything about the working of 4-stroke SI and CI engine. Okay, so I have another video, and with the help of this video you will get the thorough knowledge how the engine assembly will be carried out. Here I have one video of Porsche 911. I think all of you are knowing about Porsche is world-class car engine manufacturer company. So with the help of this video you will get the clear knowledge how different automations are there and how the different engine components will be assembled together in this particular Porsche company itself. Okay, please watch this video. This is again very informative video itself. one person, one expert is assembling this all components. This is the camshaft along with, yes, so different things if you observe clearly. Connecting rod, camshaft, the cylinder head, cylinders, everything is present over here. See, the automations is going on. This is the Porsche company. So the experts are doing the assembly of the engine. So this is the gasket as we discussed in earlier lectures. Yes, this is the gasket. This acts as one kind of a seal. So this is the camshaft to operate the valves. Another camshaft. So this is the assembly line. So many experts are there who are doing the assembly. So this is the courtesy video from the Porsche. So these are the spark plugs. So this person is fitted the spark plug inside the engine cylinder like this one. So this is the finished engine, fully assembled engine of Porsche 911 model. So this is the turbocharged engine. We have to talk on this also later on. Now the final inspection is going on before dispatching this engine. So the main intention to show this video to understand the technology, what going on in the global market to produce the engine, to assemble the engine, to manufacture the engine. Such kind of things are present in the world itself. So I hope all of you are enjoying this all videos, and you understood all the things whatever we discussed in our today's lecture about the working of 4-stroke SI engine as well as 4-stroke CA engine. With the help of all the animations and all the videos, you understood in good manner the working principle of engine. Okay, so thank you so much for watching our today's session. Here we stop our today's lecture. We will discuss the things about the engine in the next lecture. So thank you so much, dear friends. Thanks a lot.